All right. Hello, everybody. It's August 31st, and this is asynchronous work, and it's notes about stem plots and box plots, quantitative graphs, kind of how to make them. Mostly we'll be using Staplet, but this is how they're made so you can understand and interpret them. Okay, so first off, we'll go just to making stem plots. So we're going to look at data that I collected from teachers on how many numbers of pairs of shoes they own. So I sent out an email, I got back this data, and here's the raw data, kind of how it came to me. The first thing to do to make a stem plot by hand is to put them in order, smallest to largest. So there is someone with 4 pairs of shoes, and then there is a teacher with 38 pairs of shoes. So I have min and max right there. We're going to separate the digits of each of the data values. Since I really have tens and ones, my first stems are going to be my tens, and the leaves are going to be my ones digits. So when I make those stems, I'm going to go from 0, 1, 2, 3. That's because 4 has 0 in the tens place, and then all the way up to 38, which has a 3 in the tens place. Now I'm basically going to truncate these numbers. So I'm only going to record in the leaves, I'm going to record the second. So 4, 5, and 8, those are all in the leaves. So I put 4, 5, 8. For the 11 through 18, I'm going to record the second digit. So 11 becomes a 1. This 11 is a 1, 2, 2, 2, 5, 5, 5, 7, 8, 8. Those are all entered in the 1 row. And then for the 20s, I have 20 becomes the 0, 0, 0, 1, 1, 3, 4, 4, 6 recorded in the 2 column. Lastly, I've got the 3 and the 8 recorded in the 3 column or 3 row. Oh, and I put a line in between the stems and the leaves. So this is a stem plot. One thing we can do to get some more information from a stem plot is to split the stems, especially when the data is kind of clumped up like this. And how we split stems is we basically make 2 rows for each of the stems. So instead of just 1, 0, I'm going to have 2 rows, 0, 0, and then 1, 1, 2, 2, 3, 3. The ones digits, the 0 through 4, are going to go on the first 0 row, and the 5 through 9 the second. For each of the stems. So let's see what that looks like. So if I have my original data here, there's just 1 row of zeros. I'm going to split this up. The 4 will go in the first row, the 5 and the 8 the second. For this one, I'll have 1, 1, 2, 2, 2. Those will all go in the first row, and then the 5, 5, 5, 7, 8, 8 will go in the second. So redrawing this, I now have my split stems. And when I'm looking here, one thing I want to notice is that really now I get some more information. I kind of see where I've got this big clump and in the lower numbers, and then there's really sort of a 3 off here. So that tells me that there's a little bit more skew than I might have seen from this original one, which I might have described as symmetric. Let's look at comparing stem plots and how I would do that, because sometimes it's kind of confusing because it looks like just a bunch of numbers, but I really can see shape, center, outlier, spread from here. So let's first do shape. I can kind of like draw some curves here. By drawing these curves over these numbers, I can look at these like they're like little bars. And what I can see is that these both are skewed high. This data that I'm looking at right here, this is data about pulse rate from resting and then after exercise. But I can see that both resting and after exercise have pulse rates that are skewed high. So that's just what I'd write. When I look for outliers, I noticed this one, and you see how there's a blank in here for the resting at this 11. That means in the kind of like between 110 and 110 and 118, there was no values, and so that this one right here, 120, might be a high outlier. Same here, I see this gap right here in the 130s, so this 146 might be a high outlier. I put possible outliers because I didn't do the calculation. Now to calculate the center. It's easy to count the median because I can see all the data points here. So there are 19 data points in each set. The 10th is going to be right in the middle. That'll have 9 on either side. So I'm going to count to the middle value. Like 68 here is the lowest, so I'm going to count like 68, 68, 69, and all until 10. So when I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This number right here, 76, is the median for the resting. And then for the after exercise, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 98 is the median for the after exercise group. So in my sentence I write, after exercise has a higher center with median pulse rate at 98 beats per minute, while resting is lower with median 68 BPM. Finally, I'm going to calculate the spread, and I'll use range here. And I'm just going to use the most basic measure for spread, which is range. And what I will do is I will take the min and so the maximum and subtract the min. So for the resting, that's 120 minus 68. I get 52 as the range. And then for the other, it would be the max is 146 and the min is 86. And when I subtract, I get 60. So the exercise, after exercise, has a slightly larger range. All right, moving on to box plots, we're going to look at the same data. The process for box plots is also first step, put them in order. So I have them in order now, just like I did before. Now I'm going to separate them into 4 groups to make a 5-number summary. The first thing I'll do is I'll split it in half, the median. So I'm going to split it in half, and then I'm going to split it in half again. And I got to this median, there were 25 data values. So the 13th is right in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I get this 18. It's an odd number. Now that leaves 12 on either side, 12 below, 12 above. So let's find the middle of these 12. 25 was odd, so I had an exact middle number. For this even number, I'm going to have 2 middle values. And I'm going to basically average the 2 or find the middle of the 2 middle numbers. For this lower half, when I count to the 6th in either way, I get these 2 12s. So that I call this Q1. This is 12. Up here, I'm going to do the same thing. I've got 2 numbers, and right in the middle of those 2 numbers is 22, which is Q3. And then I have my min and my max. These 5 numbers become a 5-number summary, making 4 groups of data. So I have my min, Q1, median, Q3, max, and that's called 5-number summary. The next step will be to scale a horizontal axis. Make sure you scale it. Sometimes people try to put the 5-number summary in first, but it's very important that you tick and make an even scale. So I'm counting by 5s. 5, 10, 15, 20, 25, 30, 35. And notice that I have labeled the axes, right? Pairs of shoes owned by teachers. Now I'm going to mark vertical lines for my 5-number summary. I'm going to put a line at 4, a line at 12, a line at 18, a line at 22, and finally a line at 38. And now this is kind of like the skeleton of my box plot. Now I'm going to put a box around this middle. So here's my box, and this is something we call the interquartile range. This is the middle half of the data, where kind of most of the teachers are. Most of the teachers are here in between 12 and 22, and I call this kind of distance between them, I call that the interquartile range. So they kind of fall within this 10 range, and if I subtract 22 minus 12, I get that this IQR, this length of this box, is 10. So most teachers, about half the teachers, fall within this 10 pair of shoe range. And finally, I go ahead and I make the whiskers on the box and put it out that way. One other thing that we can look at with box plots that's super useful is we can show outliers on box plots. So when you do it in Stemplet, it'll do it automatically, which is great, but you should know what kind of calculation is being done. We use what's called the rule of thumb. And what we do is we look for values that are basically lower than 1.5 times kind of away from the bottom of the box from Q1. So I do Q1 minus 1.5 times IQR. And then I go from the top of the box and I go 1.5 times away from this middle, because I basically want to know how far away from the middle are they, and if they're more than 1.5 times. Somebody a long time ago decided that 1.5 times the IQR was a good amount, and that's kind of what's stuck, so that's what we do. So let's look at this. Here our IQR is 10, we already calculated that. I'm going to do Q1 minus 1.5 times that IQR. So that's 12 minus 1.5 times 10, or 12 minus 15. So if I go below that box, so I start here at this 12 and I go 15 below that, it's negative 3 pairs of shoes, which nobody has. So there are no low outliers. And let's check for high outliers. So I'm going to go Q3 up here at the top, and I'm going to go 1.5 times. So that's 22 plus 1.5 times 10, or 22 plus 15. Now there is somebody beyond what I would call this outlier fence. And I can actually redraw this graph now, these upper values, to reflect the outliers. So there is one high outlier at 38 pairs of shoes. So what I'm going to do, I'm going to take away those whiskers. And now what I'm going to do is I'm going to stop the box plot at the next lowest, which was actually 33. So I've stopped it there, and then I'm going to put a dot out there for that 38 to kind of show how far away they are. And just so you guys know, these are teachers and I collected real data. Up here at 38 pairs of shoes, our outlier of the group, that's Miss Banks. And here, this next one right here, the runner-up, that's Dolan right here, and I kind of show those. And so it gives some nice information about outliers and skew. All right, everybody, hope this is helpful. Come with questions, and I will see you all soon.